Hello, Bob Rapp here, and it's April 27th, just about lunchtime, and I want to take you through a couple different ways to think about Designer, which I think is really one of the most amazing things I've ever used in anybody's machine learning studio or AI. So the tutorial that we're going to spend time with today, and by the way, this has been done by a fair number of folks. It is, in fact, the first tutorial that you're going to use if you're running through the online training, which I definitely recommend. But it's to predict automobile prices with Designer. So I've gone into my studio, and I have a way to do this very easily. When I look at showing more samples, there's a bunch of different samples, but one of them, and it's actually the first one, is called regression automobile price. You really would just select a compute target, okay, which I've already got built. And I'm not actually going to do any parameters here. I'm just literally going to say submit. I'm going to say create a new experiment, and I'm going to call this demo 7 if you've been following along. Okay. And we're going to kind of think of this as a cooking show today. And by the way, normally my videos are about 3 to 5 minutes. This really takes more like 15 to 20 minutes. There's really no way to do it in less time, but there's a lot of concepts we're introducing here. And now that I'm preparing to run, if we look at this, we actually see that lots of things are happening. So this, by the way, says I want some data. I want to normalize the columns in the data set, which you just did. By the way, it's taking out some empty columns. Then I'm going to remove the value data. Then I'm going to split the data between a production and a data set. And I'm using linear regression. And this, by the way, is a conversation about which algorithm, which is a very long conversation. But the short story is, since we're trying to come to a single answer like a price, that's why we're using linear regression. You notice maybe that here that we split the data set 70%, 30%, so that we're training the model with 70% of the data. We're keeping 30% of the data to use for the scoring model. And each time you see the screen turn green, we have gone one step down the pipeline. Now, each of these pipeline steps can be edited. They can be used by different folks. I mean, this is a team effort here. So this is really a place that you could see a lot of people interacting here. So we're training the model now. We're going to score the model. And then eventually we're going to evaluate the model. And what's going on behind the scenes is we're taking our features, or in this case our fields, and we're saying, based on the size of the engine, based on the gas mileage, based on the model, based on the make, those kinds of things, what do we think the price is likely to be? That's the question we're asking, is tell us what you think the price prediction will be. And with this data, we get pretty close. And we could play with lots of different regression models here if we wanted to. But I wanted you to see this happening in real time. We get all the way down to evaluate the model and score the model. By the way, I'm doing this in real time. I haven't stopped the camera. I think it's taken us sort of in the 3 to 5 minute range here, which is pretty amazing. Now, as we're going through this, we could score the model and evaluate the model. We could run this many, many times. And it might be the case that we would want to run it like you recall we did in the AutoML. We ran about 100 different algorithms against the data to see which one had the best performance. And I think we had about 60%, but by boosting the data a little bit, we got to, as I recall, about an 86% area under the curve. So it'd be nice to get 99.9, but the good news is the better we do, the more we know. So, and what's happening here too is that this has trained the model. We're now going to score the model, and we're really taking a look at the data and saying, how close did we get to what we think the result should be, scoring, and then evaluating versus sort of the training data, right, versus the non-data, the data that we set aside. And again, generally it's a 70 or 80% of the data we use for training. We want to keep some back so we don't get overfitting of models. And then finally, we're going to evaluate the model. And I'm waiting here for just a few minutes because I want you to actually see this whole thing happen once. Because what we're then going to do next is do a step-by-step version to take you through this tutorial to see what actually is behind the scenes. Because, running a pre-built example that works is kind of exciting, but if you're not a data scientist, or even if you're just starting in this space, you probably want to know kind of how the car is built, not necessarily that you can, turn it on and drive away. So we're getting to score the model, and we're going to get to evaluate the model. And it's kind of interesting to look at how the model actually evaluates. And what we're going to be looking for is what was the actual price versus what the model predicted. Because remember, most of the time in business, we're saying, what's the next best action? The customer bought foo from us. Do we think they want to buy bar? We have a certain amount of inventory in X or Y warehouse. Is that good or bad? Do we need to order more? Do we have too much? Do we need to have a sale? All those kinds of things. So that's what really happened. And I want you to see this first one because if you're going through the tutorial, this will get you to the first step of the designer. And it's actually really easy to do because you notice that I haven't written any code, right? The other thing is I can share this with the whole team and we can all play around with it because the pipeline can run, each step can run independently. And I can also, and I'm going to show you in just a few minutes, I can export it to code, I can publish it, I can resubmit it. And eventually when I get the model that I like the results, then I can take that model and put that on my IoT edge with Azure, on a local computer. I can embed that in my mobile app. There's a bunch of different places I can put this model. And so publishing the model is actually really, really cool. But of course, we want to make sure that we actually have a model that we want to publish. So by the way, just so you know the runtime here, I think that whole thing took about between 8 and 9 minutes from opening the model. And but remember, I didn't make any changes to it. I just literally ran it as written on the compute that I had. And then if we want to look at the model, we want to look at the details here. So I'm going to go ahead and take a look. So we have some things here. It says, here's what happened. Here's the run ID. Here's the parameters, right? Outputs. So we can actually go and look at what actually happened. By the way, if you're a geek like me, you probably, maybe, I don't know if I'm a geek or a nerd because I can match my socks. I'm never sure. So, we look here at the metrics. This is interesting. So it says, what is the, and by the way, if you're big into coefficients and tables and other stuff, let's go ahead and look at this table here. Okay, good. We didn't do any child runs. There's no images. Was there a snapshot here? Yes. And then did we do a fairness preview? Because we are committed to fairness in AI. So that's pretty interesting. So that's the thingy that we saw here. And if we go back home and we look at the run that we just completed, right, which was just now. When was it completed? Yeah, just about now. That is the end-to-end of what the automated model would look like. Now, I'm going to actually stop and then do a second video that takes you through the manual process because it's exactly what I just showed you, but I'm going to go step by step and show you how to do it yourself. Okay? So watch this space for more information. Thanks a lot, everybody.